This is geometry, homework section for 14.4, area of regular polygons. Find the area, label your answer. It's a nonagon. Well, to find the perimeter, you take the length of a side times the number of sides. And the length of a side, it says, is 8. A nonagon has 9 sides, so the perimeter is 72. The area is 1/2 the perimeter times the apothem of a regular figure. Perimeter 72. We're told the apothem is 14. That is 504. The units is centimeters, so it's square centimeters. Dodecagon has 12 sides. To find the perimeter, it's the length of a side times the number of sides. The length of one side is 12.2. The number of sides is 12, so the perimeter is 146.4. Area of a regular figure is 1/2 the perimeter times the apothem. Perimeter is 146.4. The apothem is 8.5. That product using a calculator is 622.2 square inches. Number 3. The area of a regular figure is 1/2 the perimeter times the apothem. Don't know what the perimeter is right now, but I know the apothem is 14. The apothem, once again, is the length of a segment that goes from the center to the side, forming a perpendicular. By the way, we're assuming every figure is a regular polygon, because that's what the title of this is. Hopefully it'll be labeled better in the future. To find the perimeter, it's the length of a side times the number of sides. One of the sides is 20.3. Every side's the same. So if you multiply that by 5, you're going to get the perimeter is 101.5. Product of those three numbers is 710.5. We were not given unis for this, so it's square unis. Number 4. Now there's different formulas for the area of a triangle. Half the base times the height is real simple to use if you have the correct information. We don't have the correct information for that. We do have an apothem, so let's use half the perimeter times the apothem. We don't know what the perimeter is. We know the apothem is 4.5. The perimeter is the length of a side times the number of sides. One side's 15.6. It's a triangle. The number of sides is 3. So the perimeter is 46.8. Those three numbers multiplied together is 105.3. We weren't given unis, so it's square units. Now it's getting tough. Number 5. Say hexagon. And we know the length of a side. So the perimeter is pretty easy. Length of a side times the number of sides. That's 12 times 6. That's 72. That's not an issue. Big picture wise, we're trying to find the area, which is half the perimeter times the apothem. We know the perimeter is 72. We don't know the apothem. That's what's going to be the toughest part of this. In order to do this, we would want to find, if you don't know an apothem or the length of a side, you're going to definitely want to find the measure of a central angle. This here is a central angle. In a regular figure, a central angle is 360 divided by a number of sides. This is a 6-sided polygon, so the central angle is 60. And as lovely as it is to know that 60, it's more important to know what half of that is. Because if we draw an apothem ends up being the altitude in this triangle, an isosceles. I'm going to erase part of this, so don't draw this blue part yet. It's an altitude and isosceles triangle with the vertex angle, which means it's also an angle bisector, and it's a median. So that is to say, this is 30. If this side down here is cut in half and the whole thing is 12, that means that's 6. This is a special right triangle. These little fellows don't go away. If the short leg is 6, the long leg is that times the square root of 3. So the apothem for this is 6 square roots of 3. Did this first, we did this second, we did this third, we're going to finish this up fourth. We're going to leave that square root of 3 in our answer. So we're going to multiply 1/2 times 72 times 6 and get 36 square roots of 3, and we don't have units, so it's square units. Number 6. This is a regular quadrilateral, which means it's a square. How do you find the area of a square? It's base times height. That's pretty easy, or the base squared. But the way that we're given this information, we don't know what that is. What we can do is we can draw a central angle, and let's find the measure of a central angle. It's 360 divided by the number of sides. We have 4 sides. That makes the central angle 95. I'm sorry, 90. Now, I'm not going to find an apothem for this because I know, since these are the same length, because those are the radii of this regular polygon, if that's 90, these other two angles have to be the same. It's isosceles triangle theorem, so there have to be 45. This is a 45, 45, 90. Short leg is 6 square roots of 2. So that means this side is the short leg times the square root of 2, which means it's 6 square roots of 2 times the square root of 2, which is 6 square roots of 4, which is 6 times 2, which is 12. We now know that each side of this is 12. So I'm not going to mess around with the area of a regular polygon. I'm going to use area of a quadrilateral, which is base times height, which is 12 times 12, which is 144. We don't have any unis, so we'll just call them square unis. Number 7, this is a regular triangle. I'm not going to use the apothem for this either. I'm going to use the formula area is 1/2 base times height. And here's the reason. If it's regular, all these sides are 16. If I draw the height in a regular polygon, in a regular triangle, it's also an angle bisector, and it's a median. So that means each of these are 8. A regular triangle is equal angular. All the angles are 60. That height cuts this vertex angle in half. So we got this 30, 60, 90. Short leg is 8. Hypotenuse is twice that at 16. The long leg is the short leg times the square root of 3. So the area of this triangle is 1/2 of 16 times the height of 8 square roots of 3. That's going to give us 64 square roots of 3. We don't have units, so it's square units. Number 8 is a regular figure. It's a hexagon. And we know what the apothem is, but we don't know the perimeter or the length of any of the sides. Let's find the measure of a central angle. It's 360 divided by the number of sides. So it's 60 degrees. More importantly, when you draw a radius and an apothem, that apothem cuts the 60 degrees in half, which makes this 30. Once again, this picture I'm drawing here is just to show you where that 30 is coming from. We just found a central angle 60. The apothem cuts that in half, so it's 30. Special right triangle again, it's 30, 60, 90. "24 is the short leg times the square root of 3. If you divide both sides by the square root of 3 to get the short leg by itself, you get this. So the short leg is 24 divided by the square root of 3. If you rationalize your denominator, making sure it's not an irrational number, you can multiply by 1 in the form of square root of 3 over square root of 3. It's going to give us 24 square roots of 3 over 3. 24 divided by 3 is 8, so it's 8 square roots of 3. This is 8 square roots of 3. This is also 8 square roots of 3, which means one side of this is 16 square roots of 3. Did this first, did this second, did this third. Now let's find the perimeter, which is the length of one side times the number of sides. It's going to be 96 square roots of 3. To find the area of a regular figure, it's 1/2 the perimeter times the apothem. The perimeter we found is 96 square roots of 3, and the apothem we were told all along was 24. I believe this is 1,152 square roots of 3. Let me just confirm that. Yep. And we don't have any unis for these, so square unis. That's a tough problem. Draw the following, find the area, label your answer. Well, this one is misleadingly simple. This first one. Square with an apothem that's 4 inches. And a perimeter of 32 inches. There's a couple reasons why this problem is real simple. One, if the perimeter is 32 and all the sides are the same length, so the perimeter is the length of a side times the number of sides. The length of a side we don't know. There are 4 sides. That's going to tell us the length of each side is 8. To find the area is easy. Area is base times height of a parallelogram. Another reason why we know that's 8. In a square, if you draw an apothem to 2 opposite sides, 4 and 4 is 8, so you know each side is 8 as well. Picture, perimeter, area. Number 10, a regular pentagon with each side 5. Gonna draw this. That's not what I wanted. So each side is 5. The perimeter, so I'm trying to use the formula, area of a regular figure is 1/2 the perimeter times the apothem. Is the length of a side times the number of sides. That's 5 times 5, that's 25. Easy enough, we know the perimeter. We don't know the apothem. To find the apothem, we want to find a central angle first. So the measure of a central angle is 360 divided by the number of sides. Number of sides is 5, so the central angle is 76. Keep in mind, my table's going nuts here. Sorry. If you draw a radius and another radius, then the central angle here is 72. We are interested in the angle formed by the apothem in the radius, which is always going to be half of that, which is 36. So always cuts the side in half. That side was 5, so it's 2.5 and 2.5. We desperately, using that word pretty loosely, want to know what the apothem is, which I'm calling an x. Using right angle trigs is not a special right triangle. Tangent of 36 degrees is the opposite leg over the adjacent leg. Multiply both sides by x. Divide both sides by tangent of 36 degrees. Put that in your calculator. I got 3.44. Now that we know what the apothem is, we can find this area. Found the perimeter a long time ago was 25. The apothem we're saying is 3.44. That makes this area about 43. We have units, square centimeters, yep. There you go. Number 11. Regular hexagon with an apothem that's 4 feet. To do this, we would definitely want to know what the perimeter is. Since we know nothing about the sides, we can't find the perimeter till we know a central angle. 360 divided by the number of sides. There are 6 sides. The central angle is 60. More importantly than a central angle is the angle formed by a radius and an apothem, which is always half the central angle. It's a 30, 60, 90. Opposite 60 is the long leg. And we are saying that the long leg is the short leg times the square root of 3. If you divide both sides by the square root of 3, you get 4 over square root of 3 is the short leg. If you rationalize your denominator, you get 4 square roots of 3 over 3. That's half a side. Makes an entire side 8 square roots of 3. I'm sorry, that's 4 square roots of 3 over 3. I forgot my over 3. So that makes this entire side 8 square roots of 3 over 3. So to find the perimeter, it's the length of a side times the number of sides. The length of a side is 8 square roots of 3 over 3. The number of sides in a hexagon is 6. 3 goes into 6 2 times. So we end up with 16 square roots of 3 is the perimeter. So to find the area of this regular figure, it's half the perimeter times the apothem. The perimeter is 16 square roots of 3. The apothem, we were told straight out the gate, was 4. That's going to give us 32 square roots of 3, and the unis here are square feet. Number 12, last one before we have our algebra review. A square with a radius of 10 meters. As we discovered earlier, the measure of a central angle of a square is going to be 90 degrees. Since the radius never changed, this is isosceles. Base angles are the same. Isosceles triangle theorem. They both have to then be 45. So 45, 45, 90. Short leg is 10. That's going to make the long leg, scratch me, scratch that, don't scratch me. It's going to make the hypotenuse. That times the square root of 2. Special right triangles, know them. Area of a regular figure, I'm not going to use that formula, I'm going to use the area of a parallelogram, is the base times the height. The base and the height are both 10 square roots of 2. 10 times 10 is 100. Square root of 2 times square root of 2 is 2. The unis here were meters, so the area of this is 200 square meters. Algebra review. Solving an inequality. I'm going to get the variable by itself. If we multiply or divide both sides by a negative number, then we change the inequality sign to go the other direction. If I distribute the 2, I'm going to get a minus 6 and a plus 4x. 5 minus 6 is negative 1. If I add 1 to both sides, I get 4x is less than 36. And then if I divide both sides by 4, I get x is less than 9. At no point did I multiply or divide by a negative number. So I open circle at negative 9, which is over here someplace. And less than, we shade to the left. One below this, if we get all the x's together, if I add 6x to both sides, if I add 5 to both sides, and if I divide both sides by negative 2, no point that I multiply or divide by a negative number. X is greater than or equal to negative 3, so that's a closed circle. Greater than goes to the right. Throw your arrow on there. Graphing. Get these in slope-intercept form. If I divide each term by 3, I'm going to get a y-intercept of negative 3 and a slope of 2/3, up 2 and to the right 3, up 2 and to the right 3, down 2 and to the left 3. Throw some arrows on there, label your y-intercept. This one below is an inequality, so things are going to get shaded. If I subtract 4x from both sides and divide by 5, I get a slope of negative 4/5 and a y-intercept of 2. So I go down 4 and to the right 5. Down 4 and to the right 5. Up 4 to the left 5. Something like this. See, that's the key to doing more than 2 dots. This one right here is clearly wrong. It's not in the right spot. 1, 2, 3, 4, 1, 2, 3, 4, 5. Much better. If you only do 2 dots, you got one wrong, your line's going to be a whack. This is solid because it says equal to. Y is less than, so we shade below. Multiply these little fellas out. We got 2x times 3x is 6x squared. 2x times 4 is plus 8x. Negative 5 times 3x is negative 15x. Negative 5 times 4 is negative 20. Middle two terms are like terms, so we get this trinomial. Speaking of trinomials, segue, let's factor this trinomial. Since the lead coefficient is not 1, we're going to split the middle term and factor by grouping. We need two things that multiply to get 2x squared times negative 3. That's a negative 6x squared. Same two terms add to get a negative 1x. Let's see, that's going to be a negative 3x and a positive 2x. So these two middle terms we're coming from taking that middle term and splitting it apart. I'm going to group the first two terms together and the last two. GCF of the first group is x, leaving us with 2x minus 3. GCF of the next group is a 1, leaving us with 2x minus 3. Yes, you must factor out this GCF of 1. If you don't, you're not going to end up with two binomials. So these groups here, what do they have in common? They both have a GCF of 2x minus 3, leaving us with another binomial of an x plus 1. Fine.